Join with computer audio. I wonder how I had so many notifications of people joining my Zoom, and I start it and there's nobody in it. It doesn't make any sense. See what time's it for? 20 minutes. I'm sorry? I think it's Wednesday. No, I can't see web courses to now, so y'all will know better than me. It might not be published yet.
I'm checking the syllabus to see if it has the dates.
Sometimes we forget to update it. I had to buy a textbook. I don't remember if I said it already. I had to buy a textbook for the first time since freshman year of undergrad. Hurt real bad. I mean, it's only 160, but like, so. Imagine requiring a textbook for the class that doesn't have an online PDF.
What?
And homeboy wrote the textbook, and he won't even give it to us.
That's why.
And it's like, and you can only find it at the UCF bookstore. Nobody else sells it. Not even like Chegg, Amazon.
Have you checked Facebook Marketplace?
No, and I could have. I don't trust buying books from other people, especially since they only sell it in loose leaf. So I didn't want to like buy it and then it be missing a chapter or something, or it be drawn on because Sam draws on his diagrams in class. So it's like, okay, let's see. Yeah. Oh, actually. Oh, I wonder. Okay. Oh, hello. If you're talking, I can't hear you. The Zoom doesn't do audio on the classroom. It says green around there.
I had like accidentally said something while the mic's on, and so now I'm kind of like saving them at the last speaker.
Oh, well, see, I was just like looking at the
Sí, ya lo vi.
top. I don't know. Oh, they're saying something. I'm trying to decide how I want to do this.
No se han dado cuenta.
No.
With asking for the L solve, is that just the axis equals the A or backslash B, or is that something else?
Technically, it's asking you for lin solve, but doing the x equals a slash b does the same thing. So
the requirement.
Yeah, either one works, or both, if you feel like being cool and having both. It's up to you. I'm sorry?
I'm not cool, so.
Yeah, I feel that. I don't even have it in my code, so like. Okay.
Where's your coming from now? Check all
Oh, you know what? I don't have the connected lab. Maybe USB-C. I wonder. Doubt that works. Interesting.
No, no, it's still coming. Oh, I don't know. Oh, I should have asked about that too. What was the CS? What is the CSV write for?
It just writes your output to, or I'm sorry, it writes whatever variable that you want it to a CSV file.
Why would we want?
Make it easier to read your output because it's a 50 by 50 matrix. What do you think the name of this computer is?
That's. I have two versions. I have third one of HP for code. Yeah, this.
So I wanted to see if I could like Bluetooth connect my laptop to this computer, so that I could like draw. So I'm just like clicking random computers to see what happens. Oh, wait. Press connect if the pin matches this one. Oh, this doesn't support Bluetooth, does it? I'm connecting to a computer. I don't know what computer I'm connecting to. It says CECS 1. All right, I'm gonna not connect to it because that's too bad. I'm connect to somebody's laptop or somebody's phone. Yeah, I shouldn't do that.
I do it.
Okay, screw it. I will be getting started in a moment. Ooh, that is tiny. If my OneNote loads anytime soon, we can get started soon. Okay. Hello, welcome in.
Did you get like the weird where they get H1 or H2 as well? Yeah. Yeah, the doctor watched it.
Okay. You guys ready to get started, gang haps? Yes, no, maybe. Okay. I'll just get started in a hello, welcome in. So I'm gonna try to keep today short and sweet because if you just happen to look up my name on YouTube, you will see 2 other versions of the same exact review. And the content should not change so much that it would make those reviews useless. So there's like probably a greater than 90% chance that those reviews are still relevant. So I recommend looking into those because some of them, like I actually work through practice problems. And the ones where I go through practice problems, so forewarning, I probably made algebra errors because I got bullied is a strong word. Got made fun of for making so many algebra errors the first 2 times I did. practice problems for these reviews. But the process is still the same, and the questions are very relevant. Get that? Okay. So, you'll have to look up Maddie Messmore, so like MADIMESSMORE. I don't use my full first name on my YouTube, but anyway, yeah, there's two. I'm pretty sure there's two. Because let's see, the first semester I TA'd, I did record it. Second semester, I did record it. Third one, I did not. And I don't think I did the fourth time either. But regardless, I recommend looking at those. They're very useful. Today, I'm gonna like kind of breeze through it, not go super deep. Thank you. My brain cannot handle like trying to think what I'm going to say and also hearing input from outside, so it just doesn't work. It doesn't help that I'm really tired. Anywho, your exam, I believe it'll be Wednesday, question mark, maybe. You guys have a lecture Monday, Wednesday, or Tuesday, Thursday? Tuesday, Thursday, so I think it's Thursday then. In that case, yeah. So it should be during lecture time. I don't believe you have to be in the lecture room to take it. It is going to be an honor lock. There will not be cameras in your honor lock. So that's a dub for you guys. That always gave me so much anxiety to have the camera on me.
I have anxiety about it, but only because I was afraid that I would get my head out of the unit window or something on the correct camera.
Yeah, no, I don't blame you. They have the same system for taking the GRE, and except it's like an actual live proctor. And if you look down for too long and they can't see your face, the actual person will pop up in a window and they're like, "Excuse me, I can't see your face." It was the worst thing I've ever experienced. I wanted to vomit. I was like, "I'm sorry. I was just writing." Anywho, so yeah, lockdown. It should be 25 questions. I think the 25th might even just be like saying, "I confirm that I will submit my scratch paper." I think that's either the 25th or the 26th. 15 of them are going to be like actual math questions. The other 10 will be conceptual. And that should still be the same breakdown. Obviously, like the questions contents are going to change semester to semester, but for the most part, it's going to be like the same general structure. You're going to have, let's see, I believe 2 major like problem solving sections. Oh, sorry, somebody sent me in the chat. Open notes, no. I don't think so. That'd be kind of ridiculous for an exam. I don't know though. Read the syllabus. The syllabus will tell you for sure. I'm pretty sure it's not open notes though, because we were not allowed to have open notes when I took the class. So it'd be kind of weird if you changed it now. Even though the quiz is under open notes. But whatever. Yeah. So 2 major like math sections. The big stuff that's going to be like your actual math is going to be your root solving methods. You will likely have to solve 2 sets of like problems. I say sets of problems. It'll really be like, there will be a chunk of questions and it'll be based off of like, you have this equation in this, initial setup using this root solving method, and then like a bunch of the different steps involved. And then a second set of questions that will be another one of the root solving methods. So it'll either be, Newton-Raphson and secant, Newton-Raphson and bisection, or secant and bisection, any combo, but like it'll be 2 of the 3. I think a majority of the conceptual questions pertain to like error, number storage. I don't know why my voice just cracked. I'm reverting to like 13-year-old Maddie. Yeah, I think that's mostly the conceptuals. I mean, there's some conceptuals that kind of trickle into the other concepts, like the root solving methods. But yeah, I think that's pretty much it on the exam structure. You should have, I believe it's just the class period to take the exam. Unless of course SAS, you'd have like it's either 2 times or time and a half, whatever. Any questions about exam setup before I get into content? Speak now or have a hold your peace. What's up? I don't believe you have to. You can, and that'll give you an opportunity to ask questions if you have them, but like, I don't think you have to because it is honor law. I don't think. He should have told you in lecture. Yeah, and he might tell you Tuesday. That's a good point. So,
Understand what I've heard. You can take it anywhere.
yeah, as long as you use honor law. In which honestly, like, UCF's Wi-Fi is kind of dookie, so I don't think you'd really want to take an exam on honor lock on UCF Wi-Fi. So that's up to you. Especially, where is your guys' lecture in the VAB still, or is it somewhere else? Where's it now?
That room.
That room right there? Oh, that's interesting. Speaking of, I get to cover a lecture for you guys in November. Woo-hoo. That was way off topic. I'm just terribly sorry. Anywho, so there was a second hand. What's up?
Yeah, do we have to upload the PDF from work?
Yes. Yep. You'll have to scan. I recommend using something like, I don't know, Cam Scanner or whatever other phone app you have to upload the PDF. But yeah, there should be an assignment that gets published on like submitting your Scratch work. I highly recommend writing down work for every one of your problems. We're not going to necessarily, like, as TAs, we're not going to go through everybody's Scratch work and be like, do you have work for 1 and 2 and 3? No, but it is one of those, like, if we start to notice some suspicious patterns, or maybe you had issues with your exam, or just like any case, it's always better to try to have everything written down. That way, you know, it's like a fail safe on your side. So yeah, write everything down. And that really applies to exam 2, but it's also useful exam 1, mostly because exam 2 is a lot of math. Any other questions? No, maybe so. No? Okay, cool. So we'll get cracking into it. So first couple questions, that's going to be on error and number storage. So remember our 2 main sources of error in this class. We talked about this in project 1. Round off error and truncation error. Round off, trying to fit too much data, too small of a space. And then truncation, excuse me, is you're chopping some algorithm short in order to reasonably solve a certain number of terms of it. And whatever, you know, you leave off in that calculation, that is your error. And remember, an excellent example of truncation error is from the Taylor series. So Taylor the elephant has a trunk. Very useful to remember. Number storage, know these number lines. Also pay attention to the difference between real numbers and integers. So the biggest thing, biggest piece of advice I will give you guys for these questions, because there should be at least one of these questions on your exam, is you read the question, and like I know it's easy to get nervous because it's a limited amount of time, but like especially with this exam, there's a lot that you can easily miss because you didn't really carefully read the question. So like I recommend going through the question, especially when it gets to these ones, and being like, okay, is it asking for the largest number or the smallest number? And is it asking for double precision or single precision? And then is it asking for a real number or an integer? And then from there, you can kind of determine and like narrow down, you know, okay, it's going to be one of these 2 number lines that I'm looking at. Oh, no, okay, then it's going to be one of these 2. Or like these bounds. But really be careful to like pay attention to not only the question, but also your answer choices. Because sometimes on those, we'll give you like, obviously we're going to give you probably all correct answers. They're not going to be like random numbers. That'll be like, you know, What's the largest, I don't know, real number that can be stored in double precision? Well, the options that'll be in there will be like 10 to the 308, 10 to the 38, that gigantic 2 billion number, and then like the others. So it'll be easy to second guess yourself. Just make sure that you like stay confident, stay calm, and read the question. Please read the question. I've had so many people come to my office hours after exams and be like, why did I miss this one? And it's like, anyway, so yeah, this whole chunk. And oh, actually, I think he modified the web course. I don't think you guys have access to this PDF that I made. I can stick it in the Discord if you guys want it.
Yeah, I was gonna ask if you can zoom in to the number lines to the numbers.
Oh, yeah. Let's have two people chatting. Oh. No. Well, I couldn't hear Javier anyway, so let's see. Can I zoom in this one? No. I don't know, it's still a little blurry. Is that any better? It's negative 10 to the negative 308, negative 10, or wait, no, that's positive 308. This is negative 308. And then 10 to the negative 308, and then 10 to the 308. But this one's negative, negative, positive, positive. It's easy to remember with real numbers, because real numbers, it's like 38 and 308 are your two major numbers. And then for the most part, it's easier to pick out the integer ones, just because like most of the time when you're going to be asked for an integer, the only number that you're actually going to end up seeing is this guy. So as long as you remember it's some giant 2 number for double precision, for integers, you'll be good. Let's see. Also recommend knowing what happens when you try to store numbers that you can't. So like the major ones here, trying to store a real number smaller than 10 to the negative 308 in double precision. That's a non-fatal error, and it will just round it back to 10 to the negative 308. Now, trying to store a real number larger than 10 to the positive 308 in double precision, that gives you a fatal floating point error, and it will crash the script. So know your difference between, fatal, non-fatal. See, those 3 are the major important ones to remember. Know what machine epsilon is. We've talked about this one a lot. Pretty straightforward concept. It's the smallest value that can be added or subtracted from 0 and still be distinguishable from 0, or really it's just the smallest step size from any number while creating a unique number from the number you started at. Getting people in the chat. OneNote goated. OneNote is like great except for on PCs. OneNote, because I wrote all of this on my Surface, and then half the time when I try to open it on a PC, it crashes. But thankfully, this seems to be doing okay for now. Knock on wood. Yeah, and then converting from decimal to binary, you also have to know how to convert from binary back to decimal. It's pretty straightforward. I remember being in lecture and like kind of panicking because Dr. Kasab's method was kind of really complex. But then I talked to a CS friend and they're like, it's actually not that deep. So it's actually not that deep. So the easiest way that I found to do it is to use this modulo method. And I don't really feel like walking through it, so I'm just going to post this PDF later and you guys can look at it.
It's like doing division in 4th grade by remainders.
I'm sorry?
Like when you did division in 4th grade with remainders.
Exactly. You're just using, I mean, it's like kind of a remainder. It's like you're doing the modulo, and if it's 1 or a 0, then you use that, and then, but you start backward to move up. But anyway, yeah, it's not as scary as lecture makes it out to be. Yeah, no, that's why. So I actually, I wrote most of this out when I was actually taking the class. So this was my review for me. And I wrote this out because I watched a YouTube video on it. And I was like, wow, this is so much easier. Wow.
Your example shows that you're supposed to reverse it.
I'm sorry.
I like how clearly your example shows that you reversed it at the end.
Thank you. Yeah. I try. It's like it was. I figure since it was super helpful for me, it'll be helpful for you guys. So that's why I've been teaching like the same review document for the last like 2 years now. So yeah. Anywho, and then I have like an example here too, if you guys want to go through it. But moving forward, and then this one, yeah, decimal binary. Next thing is fixed point form. So just know what that means. It's not like super complicated. It's actually pretty fascinating. So we use fixed point form even in like grad school. I recently had to use it for a solving method. Crap, what was the name of it? I don't remember. But anywho, fixed point form, it's really just you're solving for x. And then you're setting everything that x is equal to be some arbitrary g of x function. Do note that sometimes you can have different formulas as a result, so different g of x's depending on how you solve for your x. So I will say be aware of the question type and the answer type. Sometimes our exams will have like radio buttons where you can only choose one answer, and sometimes our exams will have check boxes where you can select multiple answers. So pay attention. And it doesn't necessarily mean if it is a checkbox question, it doesn't mean that there will be more than one answer, but it could be. I don't make the rules. So yeah, I know those got me on his quizzes when I took the class. Because I'd always second guess myself. I'm like, I think this is the one answer, but I can choose multiple. So should there be multiple? But anyway.
I think back to this site.
Yeah, I mean, a lot of what he tries to do in quizzes is like, he wants you to be confident in your answer, So, I don't know. Let's see. What would indicate a good initial guess? Wait a minute. I feel like that's for. Oh, actually, I wonder if I have a formula sheet. Tell me I have it. I might have it in one. I don't want to do that again. And I highly doubt we've changed the formula sheet since 2020. Come on, OneNote, you can do it, please. There we go. Let's go. Oh, 10 years later. Oh my gosh. Okay. Formula sheet. We love the formula sheet on this exam. It is so useful. Like, quite honestly, I'd be willing to bet that if you only knew the formula sheet and you didn't look at anything else, you could probably get a 70% or higher on the exam, or higher. Let's see. Bisection, Emerson, yada yada, fixed point. Yeah. Indication of convergence. Yeah, it's all here. So yeah. My notes about this, take a look at that indication of convergence. What's up? I'm sorry? I mean, I suppose. So what I will tell you is you don't have to necessarily know the intricacies of the theorem, and that just this will satisfy all of your questions. So in essence, Yeah, all you really need to know is how to put a function into fixed point form. And then that's pretty much it. And then also to check for convergence, which is just taking the derivative of that g of x, absolute value, plug it. And then if it's less than 1, is that good? I had one kid one year one semester try to like debate fixed point form with me. I'm trying to remember what it was about.
So we just gotta know how to use it. Right?
For the most part. I mean, it won't hurt to like actually know the theorem.
Yeah.
But yeah, you only need to know how to do it. What's up?
Is there a place we can print the equation sheet, or is it passed out?
I know that the formula sheet is like in the exam. So like I believe it's at the top of every question. You can like click and it'll display the formula
Oh, yeah.
sheet. It wouldn't be bad to print it out, but I don't think he will give you a physical copy. And since this is an honors class, y'all can just hop over to the honors building and print for free. So
Is it on Canvas though?
I'm sorry?
Is the sheet on Canvas?
Yeah. It should be on like the actual assignment. I only recommend printing it out if you get annoyed having to click back and forth between the sheet and the questions, but let's see. Next, know how to do finite difference approximations. That one's pretty easy. I hope that you guys know how to do forward, backwards, and central finite difference by now. Excuse me. And y'all got the fun of me actually going in depth with the derivation of the equations. So hopefully you guys feel a little bit better about it. I'll tell you the format for the questions on these are interesting. So what it'll be, or at least what it usually is. So let's see. People online aren't able to see it, but whatever. You'll be given here. Yeah, it's right up here. Let's see, 2.1. And then 12, 4, 36, 42, 15, that matches right. Okay, so you'll be given something in the format of like this. So you'll be given a set of x values and then a set of f of x values. So this is your functions evaluated at these corresponding x's. This I vector, all it is it's like an index. It's just saying, you know, like this is the first x and the first f of x. It's really just like corresponding, you know, the second index of each of these to show that they kind of like line up. But really, you can just disregard the I. It throws a lot of people off, but it's not that deep. But anyway, so you'll be given something like that, and then you'll be asked to find, let's see, I don't know, for example, the function or the derivative evaluated at 2.35 or something. And then, you know, well, actually, let me think of a better example. Because most of the time, really what we end up doing is we'll pick, so say either a value like 2.5 or a value like 1.9, where it's more obvious which finite difference method that you have to use. And even then, I don't know if we do that for the honors though. But either way, it's more, I'm more just trying to show you guys this so that you know, hey, this is kind of what the structure is gonna look like, and then it'll ask you, you know, finite difference off of these. Usually we'll specify, you know, oh, use first order forward finite difference, and then you use it. And you just use the formula, plug and chug. Other times, and it's usually on exam 3 that we do that with the higher order finite difference. But other times, sometimes we'll be cheeky and make you use a method, and we won't specify the method, but you can only use that one method based off of whatever value we ask you to find. So, you guys are smart though. You'll figure it out. Where's all of this? Oh, that's all just like notes. Okay, now we're gonna get into the root solving methods. Since we're mostly done with the initial stuff, because now we've gone over that first chunk of questions, which is gonna be like the first 10 questions is what we just talked about just now. Now the latter 15 questions, it's gonna be stuff like this. But big conceptual questions set for you guys. There could be anywhere between 1 and 3 questions on this. Know your rate of convergence for the root solving methods.
That's the K value, right? Or no?
K value. I'm not sure if I remember where you're talking about. K value. Can you tell me what the K value is? If you remember what it is? I mean, you don't have to. I'm just saying, just the rate of convergence. It's not like a number necessarily. We'll ask you what is, yeah, it's like linear, superlinear, quadratic. So Newton-Raphson know that it's quadratic, but if there's a double root, then it's linear, which I will tell you guys right now, it's a little secret because this got me when I took the exam, I got it wrong because I didn't pay attention when given a problem to solve with Newton-Raphson. This problem happened to have a double root, but I didn't realize it because it wasn't like pulled out to be like x minus 2 times x minus 2. It's, you know, it's a double root at 2. I didn't pay any attention to that because I just saw x squared, yada, yada, yada. What'll happen is you'll be given a question and then, you know, you go through the steps of solving, you know, oh, Newton-Raphson. But then it'll be like, what is the rate of convergence for Newton-Raphson at this problem? Well, you might initially want to say quadratic, but make sure to double check that it's not a double root. So it won't, the question won't necessarily be, you know, oh, what is the rate of convergence for secant? It'll be like, what is the rate of convergence of using Newton-Raphson for this problem? And then you'll actually have to check. Now it might actually say that secant question too, but critical thinking. Bisection, that converges linearly, and secant is superlinearly. Also know that as your step sizes get closer and closer to 0, your truncation error does decrease, but your round off error starts to increase as those step sizes get smaller and smaller. But we've talked about that in the lab already. And then know all of the steps for all 3 root solving methods, especially since you guys don't know which 2 methods you're going to be questioned on. You should probably just know all 3. But they're not hard, and the formula sheet gives it to you. So.
You said bisection converges superlinearly and then secant converges.
Yeah, it's in the green up at the top. I don't know if you can see it super well, but making me, whoa. Yeah, but then once I zoom in on this, it cuts off everything else. Oh. Okay. So, and then that's the beauty. The last 15 questions can pretty much just be answered with the formula sheet. Because if you look at the formula sheet, it's basically the same thing as what I have. So like, it gives you the steps to quite literally just do it. How to find each of your X update values, how to find your residual, how to find your convergence. And it does that for Newton-Raphson and for secant too. So what's up?
Dumb question. But for those, right? Let's say we wanted to do, I guess, in my reading, if you pick like a value like 2.15, use forward or backwards, doesn't really matter. Where would there be like a specific case where you will have to use like backwards, or like if it's not outside the bounds?
If it's not outside the bounds?
Yeah.
Then there wouldn't be. Then we would specify which method we want you to use.
Okay. So you can just use whatever and outside. And then it's inside the bounds.
Yeah, so if it's inside the bounds, we'll tell you which method to use because there's multiple that you can use. But if we don't tell you which one to use, it means that there's only one that you can use. You have to figure out which one that is. So yeah, anyway, yeah, back to this. Just remembering bisection method. This one, I'm gonna go on a little tangent. It's interesting. I actually had to relearn. I say relearn. We did a review of it in my biomedical modeling class this semester. It was like, is that Wednesday? Yeah, I think it was Wednesday. But my professor, Dr. Fu, he does it totally differently. So I like, he started the lecture and he's like, oh, we're gonna go over some review of root solving methods. And I was like, yeah, I don't have to pay attention. And then he started going over bisection method. And I was like, yeah, binary search. And then his X update, I wonder if do I have my book with me? His X update was different. And I was like, wait a minute. Have I been teaching bisection wrong this whole time? But no, it was just fascinating. Let's see. I can throw all my notes. This is some of the most notes I've ever taken for any class. It's kind of painful. Oh, where is it? Ah, okay, wait, here we go. No, maybe it was Monday. Yeah, here we go. Yeah, okay. So like his X update, he used, you create some H, which is really just the halfway step, like value between the 2 points that you're using. And then in order to determine whether or not you're converging, you multiply the function evaluated at the last X times the function evaluated at the newest X to see if it's positive or negative. And I was like, okay, this way is a lot easier. So wild stuff. Anywho, with this question type, so I highly recommend, do I have it on here? No, I don't. I highly recommend making a table. I know I sent this to you guys when I first talked to you about bisection method. But you'll be given a function. You'll be given an initial A and B, so your initial low and high bounds, or high and low bounds, depending on how it's set up. I'd recommend just starting out, make a table and be like, okay, this is our A, and then in the next column, the function evaluated at A, and then B, and then a function evaluated at B. And then when you find the midpoint, which will be like your X1 or X0, however you want to specify it, you put that in there, and then the function evaluated at that. And then you can compare your bounds and be like, okay, which order do I need to make it so that the bound has shrunk, but also it still has a sign change between the 2 points, right? So that way, as you go through, you'll have everything kept track of. So you know, yeah. Let's see. And it's also not a bad idea to do residual and convergence for each of those and include that in the table as well. Sorry, Will. Have like an extra column for residual and convergence. However, I will say we don't make you guys do more than like 2 steps of this. Because if we made you guys solve it all the way to like a tolerance of 10 to like the -6 or whatever, it might take you forever, and that's kind of unrealistic. So it'll usually just be like, oh, what is your next X value after you're given your initial bounds? And then you give it, A plus B over 2. And then it'll be, what's the convergence at this update? What's the residual at this update? And then what would be your x2, so the next x value? And then what's the residual, the convergence? And then that'll likely be it for that question. And then maybe like, what's the rate of convergence? Oh, and then there also will likely be a question about this. So whatever number of iterations is required with, so with bisection method, this is also on the formula sheet. So the number of iterations in, I struggle saying that letter. You can find that by saying, okay, 1/2 to the n times b minus a is less than your tolerance value, and then you solve for your n. I think the formula sheet even has like a nicer, yeah, they actually solve it for n on this one. So it's given to you. So yeah, you don't have to forget about it. You'll just have to actually be able to solve it. So I have a calculator, please. Let's see. The next one, Newton-Raphson. So yeah, know how to do Newton-Raphson, know how to find it. We talked about this we talked about all three of these methods really in depth on project 1. And if you need to go back and like re-listen to what I said, I'll just leave it at that. Yeah. Anyway, so yeah, know how to solve these. Make sure you know how to do the residual and convergence for each update. What's up?
Question. Bisection, the way you check to see if there was a root is just check for side change, right?
Correct. Yeah, it's the, why do I always forget the name of it? The theorem, and we learned it in like Calc 1.
Intermediate value.
Is it the IVT? I think so. And it's, well, it's specifying on a continuous function bounded by A and B, if there's a sign change between A and B of the function evaluated at those points, means there's a root between A and B. That's all it says. I always forget. I could look for it, but because OneNote takes 10 years to load, I'm gonna not. You don't need to know the name of the theorem, but yeah, it's just based off of that. What's up?
You said go back and listen to what you said before. Are the previous lab recorded?
I'm not going to answer that question.
This guy, there's this guy on YouTube that has something that looks like that. I'll text you.
The person also has a very similar link for that too, right?
But it's not her.
Also, I think my TA from when I took the class still has videos up. He's awesome. Rodrigo Duran. He's a king. I don't know where he is now. He went to Sandia National Labs. But he's still active in the UCF grad Discord, so I don't know what's up with that.
What's his last name?
Duran, D-U-R-A-N. Let's see. So yeah, anyway. Newton-Raphson, you'll be given your function, and you'll be given an initial guess. Oh, fun thing. Try to remember your project for this one. There could be recurring quiz questions. So, remember what you have to have for secant method versus what you have to have for Newton-Raphson. Like Newton-Raphson, you only have to have the function, be able to either have or obtain the exact derivative and then an initial guess, versus secant, you just need the function and 2 guesses. No derivative, no exact derivative, right? Because you approximate it with a finite difference. Whether forward or backwards finite difference.
But like better.
Pretty sure we use forward or. Wait, what do you mean? Okay, because central finite difference is very different from the secant update formula. All right, I'm not going to question it. Anyway, Oh, yeah, this is important too. Fixed point theorem. To check your initial guess. I think that's also on the formula sheet. Or maybe not. Yeah. Yep. All you have to do is put the function into fixed point form and then take the derivative, absolute value. And as long as it's less than 1, it's a good guess and it'll converge. So yeah, that will very likely be a question that you'll be asked if you have to do the Newton-Raphson questions. So know that. Yeah, no, we talked about this. Yeah. Converges superlinearly. I think that's it. So we don't have any like matrices or matrix stuff on this one, thankfully. All of your matrix fun is going to be exam 2. I think literally all of the matrix math is exam 2. Because once we get into exam 3, we're done with matrices. You had me totally second guessing there on whether the secant update is central finite difference. I was like, wait, is it?
No, it's.
No,
X,
it's this.
Not minus.
It's this whole thing.
Not over. But it's over like a central finite difference.
I think we usually use backwards finite difference. Because,
That's if your guess is off. No.
I'm sorry?
Is if your guess is on point, if your 2 guesses, it'll like to be.
If you get,
If you have like 2 good initial guesses, your location of like your 0 will be between.
if you have 2 good initial guesses. Depends on your definition of good. Okay. Fair enough. Maybe you're just too big brained for me. But I think that's the majority.
My command window is just tiny and I would prefer to not.
Okay, I'm not answering any project questions right now. So
Just tell me
please,
to fix my screen.
I can't do that right now. We're doing an exam review right now. Yeah, I think that's everything. Anybody have any questions? Yes, no, maybe so.